Big data technology in construction. The development of information technology leads to an avalanche-like growth of the volume of structured and unstructured data, called big data. Today, companies have to deal with petabytes of data. For example, Google processes more than 30 petabytes of data per day, Facebook receives more than 10 million photos per hour. Presumably, by the year 2020, the amount of data on the internet will increase to 50 zettabytes. Today, big data is compared to oil of our time. The availability of big data allows you to take a fresh look at various areas of human activity. One of such areas is building information modeling, designed to collect multidimensional information about the construction site with the support of interdisciplinary cooperation of stakeholders. BIM data is usually compressed in various proprietary formats in 3D coding. These various data collected in the BIM model are constantly updated in the process of design, construction, and operation and are saved after the end of the service life of the objects. BIM files of a building model easily reach the size of 100 gigabytes. This data in any format and form is of great value for the industry. This vast amount of BIM data is pushing the construction industry into the big data era. Big data has certain parameters: firstly, their size, terabytes, petabytes, data exabytes, etc. Secondly, many heterogeneous data formats, such as text, audio, video, graphics, data from sensors and much more, and third, the transfer rate. Construction data is huge and can be classified into various file formats. In addition, the data is dynamic, due to the stream nature of data sources, such as sensors, RFID. Using this data to optimize the design, construction, and operation of the next frontier of innovation in the industry. Today, the task of developing methods for estimating the parameters of big data, defining approaches to their structuring, accumulation, testing and storage, as well as determining the relationship between formats and their streaming is becoming very important for making management decisions. The rapidly developing technologies lead to the fact that electronic devices are becoming smaller and more powerful, and high-speed internet becomes cheaper and more accessible. This has led to the emergence of various devices connected to the internet, and, ultimately, to the emergence of Internet of Things, IoT, technology. The basic idea is to integrate smart devices and vital control objects over the internet. Combining the physical and digital worlds creates exciting opportunities. IoT is successfully applied in all industries, including logistics, transport, smart homes, smart buildings, energy, and defense. The study conducted by the author showed the possibility of using RFID to monitor construction and quality control, as well as, if integrated with BIM documents, to quickly search and locate objects. Using IoT in construction represents an unlimited number of use cases and requires thousands of sensory devices for data collection, which requires working with big data. With the development of digital technology, a modern building is becoming a complex intellectual system that includes such subsystems as building automation, life safety, telecommunications, user systems, facility management systems, management and interaction with building maintenance services. Smart building integrates technology into building systems through a single look. These systems generate huge amounts of data. For example, an approximate calculation of database volumes showed that for 8 months, more than 2 billion data will be accumulated, which reaches the limits of conventional relational databases. To overcome this limitation is possible only on the basis of the implementation of big data technology. Solving the problems of smart city to improve the functioning of urban services based on big data analysis opens up new perspectives for developers and data analysts. For planning urban infrastructure, it is important to track the geolocation of urban events that attract a large number of people, such as sports events, festivals, concerts. Developing a system for processing, collecting, and storing data is engaged in big data engineering, which allows you to process petabytes of data and provide access to various user applications to the results of data processing. This requires specialists with good programming skills, knowledgeable network technologies that can interact via the internet and work professionally with computer equipment. Big data analysis includes the development of various classification and forecasting systems to study trends and patterns, followed by the interpretation of the results. To work with data analysis requires specialists who own the methods of search, selection, grouping, analysis, integration and visualization of data. One of the available tools for processing big data are the open-source platforms Apache Hadoop and Apache Spark, which allow you to process huge amounts of semi-structured data from heterogeneous sources. However, studies using data processing on large buildings are rarely used to process data from BIM building information models, since the data is interrelated and very relative and difficult to distribute across different Hadoop blocks. This placement leads to a decrease in query performance due to the increase in disk input-output required to merge sparse data for analysis. To overcome this, you need to develop a pre-processing and data exchange module that allows you to analyze and split the logically relevant portions of BIM data, by floor number or material family, storing them in adjacent Hadoop locations. To make the most of the CPU, you need to enter multithreading during data analysis. Cloud computing is an internet computing paradigm where access to demand is provided to a common pool of customizable resources. The idea of this approach is to transfer the data warehouse and perform calculations to third-party data processing centers. As a result, it becomes possible to simultaneously access cloud services for multiple users without the need to purchase separate licenses. The author used the cloud for context-sensitive computing based on BIM. Google SketchUp, Google Apps, Autodesk BIM 360 and Viewpoint were connected to the Amazon EC2 cloud to support most of the designer's features. An attempt was made to integrate cloud computing with the latest technologies such as VR, AR, and social networking business services, creating a virtual environment for better visualization and understanding of BIM models. Cloud computing can significantly accelerate the introduction of IT in the construction industry, transforming many specific tasks in the design, construction, and operation of buildings. The role of big data in this transformation is huge. Conclusion. 1. Using big data technology in construction is not enough. 2. Huge amounts of data obtained by the construction industry during the entire life cycle of a building are not fully utilized. 3. The development of technologies necessary for storing, computing, processing, analyzing, and visualizing big data demonstrates an increase in the efficiency of construction processes. 4. As a result of the research, it was established that the introduction of the latest, very flexible, and powerful big data technology is proceeding slowly, despite the fact that analytics based on this data has been used in the construction industry for a long time. 5. The demand for big data technology is growing with the emergence of new trends in building practices, such as BIM, IoT, cloud computing, smart buildings, and smart cities that have great potential to use. 6. The need to train highly qualified specialists in the field of information technology, owning big data technologies in relation to construction. Thanks for your attention. Big data technology in construction.